Hello
So,
everyone. This is welcome to the first class of day two. We have already met Malay yesterday, and he will be taking a class on beautiful geo things stuff. I don't know what it's going to be about, so it's looking forward to it. Over to you, Malay.
hello everyone. So today I'll be doing, just give me a second. So today I'll be doing, I almost took the wrong pen. So today we'll be doing some geometry problems. There is some underlying theme behind these problems, and I'll mostly be doing problems where, the idea is to introduce some point, and, it's like, oh, we want to prove this. So how we want to say we want to prove some angle condition, and we are like, oh, how do I think of this? So maybe work with the angle condition and you realize something else has to be true. Say something about the second intersection of circles must satisfy this. So now you instead try to prove that condition and so on. So yes, and I'll be giving motivation about it. A couple of general instructions. If you have any doubts at any point, feel free to interrupt and ask. And as you might have seen in yesterday's class, my handwriting is terrible. Feel free to ask me if you can't read something. So to begin, let's start with this problem. And if you have seen this problem, let me know. I'll give you a buffer problem. Oh, right. Yes. Thank you, Om. My diagrams are probably the best in the world. So I would recommend you to draw your own diagrams, or else you won't follow the beauty of my diagrams. So let's get started. Also, please, I won't be calling this point. It's fine, leave it. The problem says segment. So this you just have one intersection here. Let's write over here and uh,
Is omega the circumcircle?
wait. Yeah, can you speak a bit louder?
Is omega the circumcircle?
Omega is
Okay, omega is
circumcircle
circum.
of APQ.
Okay, that omega.
I think you should draw center circle APQ because if you have circle, you should know where the center is usually.
Okay. Okay, that's good. I have succeeded in drawing this. And now I have to draw BSC. I won't be drawing circle BSC. Um, and this is O. So you want the center of APQ. What do you want me to call it?
O dash.
Yeah, so if you get any ideas, unless you have seen the problem before and you just remember the solution, you can give your ideas. And prefer talking, unmuting and telling rather than we just need to show tangent at APQ at Yes, that's true. Also, there are like tons of solutions on the thread, and so there is a high chance the progress you give would be a part of some solution, but I would be discussing the solution I have come up with. So yeah.
We can try inverting around APQ and prove that PSC forms a tangent at S.
Okay, yes, that's a good idea. Okay, so first of all, do people know? So suppose you want to show two circles are tangent at S, like the problem says prove that two circles are tangent at S. How do we convert this to a angle condition?
We can show that angle QSC is the sum of angle QBS, QPS and SBC.
Yep. So, okay, center of circles are collinear with us. That is one thing, but in that, okay, sure. But here I will be doing angle chase, and the angle condition that we do is so if you show that. Also, in that case, you would, yeah, okay, that works too. But angle PSB equals angle PQS plus angle SCB. I'll mark the angles. So what it says is that if you consider the angles 1 and 2, angle PSB should be 1 plus 2. And the reason is you simply draw the tangent. This angle must be 1 and this angle must be 2, and this is if and only if they are tangent and so on. So we have to prove this angle condition, which is same as showing the tangency. So is this clear to everyone?
Yes.
Good. The centers collinear, at least here. Okay, maybe it's still possible. Linear to the center. The center of BSC seems a bit hard to deal with. And what about us? Yes, that's a good idea, but unfortunately, I won't be doing it. I think any radius, that should be fine. Yeah, okay, also, yeah, would be like inversions might work, but so I won't be doing inversion. Maybe like if you want to complete on your own, sure, but for context, I don't know the full inversion solution. I mean, I have not seen myself, but they might exist. But for this problem, we'll just be doing angle chase and yes, basically just angle chase. Right? Yes, just angle chase. Okay, yes, that's good. Okay, so let's look at this condition. We want to show So you have, and I won't be doing bashes in any sort of bashes in today's class. So we do have a point S here, and we want to show this angle. We have this is parallel to this, and we want to show this angle is addition of these angles. Did you say anything?
I don't know if it will help, but AO meets at the midpoint of BC. Like that's one observation.
Yes, that works. That's good. By Seva's theorem, we know that AO should pass through the midpoint of BC.
Also, the angle at O, like angle POB, is also equal to that thing. But it's not.
POB equal to what?
Is angle POB equal to angle PSB? Not sure.
It's not.
It's not?
It's not.
Okay.
POB is not equal to PSB. So
Do we know it's not equal? Like, is it known it's impossible for it to be equal? Or
yes,
that it's
unless
possible for it
I
to
mean
be unequal?
yes, it's not possible. I mean, you'll see the reason in some time. Maybe try to figure out why it's not true, but I'm saying it just can't be true. Okay, so as pointed out, AOM are collinear. That's an important observation because by Seva's theorem, BP over PA times AQ, because PQ is parallel to this BP here and so on. So the three Savian should conquer and it satisfies. So is it clear why BOM are collinear? Where M is the midpoint of BC. I should write from is midpoint of BC. Okay, so this angle PSB is a bit weird. Can we, if you look at this thing, can you convert it to something nicer? Like so far, the only thing where we have used PQ parallel BC is to show that AOM are collinear, but as of now, we don't see anywhere to go with it because M seems completely random as of now.
Yes, PSB is equal to QPS plus SBC.
Sorry, can you repeat? Yeah, okay. Can you repeat just to confirm?
Yes, angle PSB is equal to QPS plus SBC. So that is
QPS? Wait, how is it this angle plus this angle?
no QPS मतलब वो अलग
Yeah.
QPS.
Yes, amazing. So observe that angle PSB is equal to angle QPS plus angle SBC. That is, these two angles add up to this, and the reason is just draw a parallel through S. This angle must be equal to this, and this angle must be equal to this. So now we want to show that this angle, the two orange angles add up to the two red angles.
This is probably not true, but does A dash lie on the circle BSC by any chance?
No, it's not.
That makes sense. Yeah.
But yes, that was a good clue. No, but yeah, okay, yeah, that's not true.
Should we
So we
like
want
add
to
the LCs for the red angles because we have two cyclic quadrilaterals?
two cyclic things. Where are the can you explain your idea?
Like APQS is cyclic, so like we can like angles is there.
Okay, okay. But we only have one circle, that's an issue.
Yeah.
Okay, so we know that angle PSB is equal to, just give me a second.
So if we have PSB equal to QSC, then we're done.
Yeah, I was about to say that.
And this seems like a better thing to work with because it's like symmetric in like all the right ways.
How do you get if PSB equal to QSC? We are done.
Because QSC is equal to SPQ plus SBC by the same lemma. So
QSP is equal to what?
because now we have
QSP is equal
QSC equals to like PQS plus SCB from the same lemma, and we have, and then that basically just implies the tangency. So
Yeah. So what do you have to prove that S is collinear with BQ? That seems
I
wrong.
don't think that's necessary.
Oh yeah, it's ulta. Sorry.
Yes, sorry for that. So yes, that is a good observation. We want to show PSB is equal to QSC, and as pointed out, we would be done if we show that, because we know that this angle, because by symmetry we want to show that this angle is equal to angle QSC. I mean, I considered angle PSB at the start. I considered this angle, right? I could have considered the other angle, and I just have to show this thing. This is what the problem asks us to show. I mean, you can do it with this if you want as well, but I want to show QSC is the sum of these two angles, and we know that is PSB. So what it just left to show is to show that PSB is equal to QSC, and that's definitely better.
I think that since S is a very weird point, we should write PSB in terms of PO and PA dash, because right, we can do something like that. For example, we have a PSB will just be we can have quadrilateral TPOS. So in this case, PSB will be DOA dash plus A dash A dash BC OBC 180 minus that, right? We can just do 180. So
Yeah.
ODS, and we should do that to get rid of the S kind of, because S is very weird and not good-ish, if you're getting what I'm trying to say.
Yes, but we will have to keep S because we have to use the fact that APSQ a cyclic A or AO, like that other
S
angle
right
condition.
now is having too many conditions on it for us to get rid of it in a nice way.
Exactly. But yes, it would be easier if we get rid of S in some way. So is everybody on board so far?
Yeah.
Cool. And okay, we also have to use the fact that A dash is the reflection. So also remember that.
I mean, it's possible that some details are just there to like kind of give a false sense of the problem. In a sense, maybe obscure things.
A dash
That's
is
possible.
necessary, I think.
A dash-
I think
A
it
dash
is
is
necessary because,
relevant.
yeah, because if it was not A dash, we could just have different S on that APQ circle. So that does not
Yep. And remember, APSQ cyclic, we haven't thought of that. So we had this claim, which is angle POB is okay, not a claim, but kind of unclaimed, which is POB is not equal to PSB. So I don't. I think Shreya had the idea. Why were you trying to see if POB was equal to PSB?
I don't know. It just seems okay. First of all, that would prove the claim because angle POV will be
Sure.
equal to angle
Yes.
PSB.
Yeah. Okay.
But it also
Mhm.
seems like a very nice property. Or it
Makes
looks
sense. Makes sense.
true in this diagram.
I see.
I think we can probably extend BS and CS towards different angles.
Can you speak a bit louder?
I think we can extend CS and BS to use different angle conditions to prove.
I see. So you're taking the second intersection with APQ. Okay, not a bad idea.
Okay, Debarchan is saying in the chat that homothety seems like where his intuition is going.
Yeah, but homothety about what?
Most probably A, but I'm not
Sending
sure. Like I had done a similar problem with a similar setup where
I
some
mean, homothety kind of makes sense because like APQ and ABC are homothetic, but I'm not sure how exactly you'd implement it.
The issue is A dash is in terms of ABC and PQ is a random line parallel. If you directly do homothety, then you lose the niceness of A dash.
yes,
Could
that
could S be the midpoint of arc PQ?
Okay, that's a good claim. Could S be the midpoint of arc PQ? And it's
What is arc?
arc PQ.
Ah,
Arc of a set. No, it's not true.
AB A dash M looks like a rhombus.
A B A dash M.
M. Yes.
No, that's just
I mean, that would sound
no.
like something which shouldn't be true because then AC A
Yeah.
dash M should also probably be a rhombus by symmetry.
I mean, if AB A dash M is a rhombus, AB should be equal to AM, which is just not true in general, right? Intercept A dash. Okay, that's a good idea. Yeah, maybe that might work. But today I want to do a solution with just angle chasing. And yes, I would definitely like encourage you to try your ideas that you have. Okay, so now we are just left to show PSB is QSC, which is kind of interesting because we have these two equal angles about S, but we can't work about angles about S. So we want to change it to angles about some other point. And we had this idea, which we thought was like, oh, we just go to angles about O, but that's not true. What would we introduce some other point so that we get angles about it? Like convert this. Yes, perfect. So we introduce SPB cap SQC. So I would like to talk about this. So this idea is what I call adding the second intersection. And in a lot of cases, it's not so obvious of why when you add it. And here, what is the motivation behind adding it is that so we want to show that these two angles are equal. But as I just said, working with S is a bit hard. So what do we do? If we introduce the second intersection, observe that point will also satisfy the same angles. So maybe through that point we can reach S, and there is a chance that the second intersection follows something which is which is easier to work with than S. So introduce the second intersection of BSC and second intersection of these two circles. Does anybody have any observations? Other than the fact that that point also has the same angles about this.
Should lie on BC.
Great. It should lie on BC, and that is why POB cannot be PSB because this means PBSO cyclic. But the second intersection, PBSO and similarly QC, SO cyclic, but the second intersection should lie on BC. And this is just angle chase. The reason is angle B, and this is where we are using for the first time APQS.
This is like Mikhail point, I guess, right?
Yes. So for those of you who know S, like S is Mikhail with respect to something.
What is
So
Mikhail?
it's fine. You don't need like it. Just this it's just a note. It's just a thing. It's just a name. You don't need to. So if you take any 3 points and consider these circles, they would conquer at a point. Say call this ABC, call this DEF, and this as K. Then you say K is Mikhail of DEF. And that's it. That's nothing. So it's fine if you haven't heard of this. So the point is because because APQS is cyclic, we know angle BPS is going to be 180 minus APS. And so consider the second intersection, call it P dash. We would have angle B P dash S. No, sorry, what am I doing? So if P dash is the second intersection, then we would have angle B P dash P is equal to sorry, I'm thinking of a different angle chase. My bad. So if you look at angle S P dash B, that should be equal to angle APS because it's cyclic. And similarly, angle S P dash C must be equal to angle AQS. But the point is these two angles add up to 180 because APQS is cyclic. So SP dash B and SP dash C add up to 180. So it lies on BC. So is this clear to everyone? The second intersection should lie on BC. So I'll just mark this somewhere. Let's probably mark it here. And this is P dash.
P dash is second intersection of PS. P dash is second intersection of
X. Sorry, call it X.
QSC and PSB, right?
Yes. Yes. The two circles, this is X. And the point is it should lie on BC. So what do we want to show? We want to show, I'll draw it once more. So we have ABC. We want to, we have this PQ parallel this, and I want some, and remember this point X also satisfies the same thing. X is second intersection. So we want to show these two angles are equal. X is the second intersection. So can you get some more information about X? So yes, this is, yeah.
We want to show that XP is equal to XQ.
Great. Because PQ is parallel, we want to show these angles, these angles are the same. So we want to show XP is equals to XQ. And remember what I meant by seeing the second intersection, maybe it satisfies something nicer. And well, first thing that you observe is, oh, it lies on BC. So that is a big information. And secondly, we want to show XP equals XQ. So that's great. So we are just left to show that.
So how do we know that X is below Q? X is below S?
It doesn't matter, right? Because it
does
lies
matter,
on BC.
right? I mean,
it
you are
lies on
assuming,
BC. So
I mean, you are assuming that X is on the different arc of OC than Q. How do you prove that X is on the, like, I mean, X could have been on the same arc as Q.
If it's that big of an issue, just directed angle chase.
Yes, you can just do directed angles. That's fine.
I don't.
I mean, you can just, in fact, I think you can even do all cases if you really think it could lie on the other arm.
Can you just please, sorry, but explain why you think, at least give a reason why X should lie on SC, on the arc SC instead of the arc SQC?
I mean, you have a circle here and you are considering this circle and this circle, like, so how can this point lie somewhere here? No, I mean, it's just angle chase, right? Like by angle chase, it just lies on BC. You don't have to show it doesn't lie on the other arc. Or if you want, okay, Or if you want, just introduce this intersection. Consider one circle, keep the other intersection, and just show that these four are cyclic. If that's easy for you. Okay, so we just have to show xp is equals x cube, where x is the second intersection. And
This
is
is
there
all of a sudden much nicer because then that means that x lies on the perpendicular bisector of PQ, and suddenly like perpendicular bisector and A prime will be parallel, and that's pretty nice, I think.
okay? That's a good idea. Finally, we are seeing a prime coming into picture.
And we might want to introduce then the midpoint of PQ as well.
Okay, that's good. And where would the midpoint of PQ lie?
It would lie on like line AOM because of homotherapy.
Yes. Yes, because of homotherapy, it would lie on this line, and I'll be calling it. In fact, we don't need M in this problem. I'll just call the other point M. If you want, I'll keep this M dash, and let's call this D. So do you have any guesses? So clearly point X must be something really nice because you have XP equals XQ and X lies on circle.
Oh, so X has to equal M.
Okay.
No, it doesn't. Sorry, my bad.
So we need to prove that XM is perpendicular to PQ. But then if we introduce AD cap PQ, then we just have a cyclic chord. We have to prove that it's cyclic. We need to show XM perpendicular to PQ, right?
I think Malay has frozen. No.
No, he's not.
Oh my. Does the second intersection lie on a dash? Oh. Okay, that's a
Can
can you give the motivation behind that? Just something if you thought. And yes, the claim is true. The point X lies on the line A dash O. So, well, the motivation I actually had for it is, I was like, when I was trying, I was like, oh, I have to at some point use A dash. You have this point O somewhere, you have, okay, I'll just draw the entire figure. It's okay. So you have PQ, ABC, and you have dash, which is the reflection. And if you introduce this point X, because A dash is the reflection, you should have that these angles are the same, right? Because A dash is the reflection, just because of this. This is fine for everyone, right? Why the two green angles are equal.
Yes.
Yes.
Yes, because angles 1 and 2 are equal, but this is same as angle 2. So, and okay, what do we want to show? We want to show that, okay, just think of this as the same X for now. What do we want to show? Oh, I should use different color. What do we want to show is that this angle we want to show that this angle is same as this angle. We already have a pair of we already have a pair of equal angles about X, and we want to show one more pair of equal angles. And there's really high chance the same point satisfies it. Yes, you can do DDIT. In fact, by DDIT, you can directly show that if you introduce X as I'll tell it. I won't be doing DDIT. I'll be just telling the isogonal line lemma as it's called. If you introduce X as A dash O cap BC, then we know that it satisfies the green angles. Then in fact, we can directly infer the two pink angles are also equal. So for those of you who know isogonal line lemma, okay, I'll just write the statement. So you have two lines, and say you have isogonal lines. Suppose you have these 2 points P and Q, which are isogonal. When I say isogonal, it means it makes the same angle. So what it says is that if, okay, I'll write if PQ isogonal in angle BAC, then BP cap CQ and BQ cap CP are also isogonal. Yes, as I've said, I'll stick to only angle chase. So I'll give you a angle chase or length solution as well. But this is for just the people who know are also isogonal. So if you introduce this point and this point, they are also isogonal in angle A. So how do you see it here? You apply it on, you see, you look at angle AXO. In angle AXO, B and C are isogonal. So BO cap AC and CO cap AB, which are P and Q, are also isogonal, for those of you who know. And for those of you who don't know, we just want to show, so here we introduce this point as X. So I'll be redefining X as it's A dash O cap BC. And what do I want to show? I want to show that XP equals XQ, right? So as pointed out before, I want to show that XM is parallel to A dash. Because I know that A dash is perpendicular to PQ. So XM should also be perpendicular, and M lies on the perpendicular bisector. So XM should be the perpendicular bisector. And this you can just do by even homothetty. I think what you do is A dash X by XO is, remember, X I have defined as A dash X cap XO. A dash O cap BC. A dash X over XO would be distance from O to BC, distance from A dash to BC, or distance from O to BC, which would be, I'm just dropping perpendiculars, which would be, because A and A dash are reflections, I can do this. And now again, by a homothetty, you get distance from A to PQ over distance from O to PQ, which by similar triangles is AM over MO. So what you do is you drop all perpendiculars from O to BC, and you drop perpendiculars here, and then you just keep chasing ratios, and you get A dash X over XO is AM over MO, which implies XM parallel to A dash. So is this clear to everyone?
Yes.
Okay, cool. So now I have defined, X is A dash O cap BC, and I have shown that XP is equals to XQ. Is it fine for everyone? Okay, so what are you confused about? Okay. But now we still have to prove that XP, SX, and SXQC are concyclic. So now our goal has shifted. We were assuming that. Now we have assumed something else because this is easier to work with. And so now our goal is to show that, to prove that BPSX and CQSX are cyclic. So is everybody on board so far? Should I go over some part once more?
We go over the A dash X by so the part where you did A dash X by A dash O is D A dash BC, and yeah, this part.
Yeah.
Why is
Do
this
you want me to explain?
Yeah.
Okay, so a dash x over xo. So you want a dash x over xo. You just drop perpendicular from O and perpendicular from a dash. Because of similar triangles, it will be the distance of the two things. Okay, I'll draw a picture here. Just think of this as perpendicular. And you have this O here. This is x. So so a dash x over, it's going to be this length over this length, right?
Okay. Yeah.
But this, as I said, my diagrams are beautiful. The two blue lengths are equal because a dash is reflection. And these two lengths by a homothety are equal to this length over this length. By similar triangles, this is equal to this length over this length.
Okay. Yeah. Thanks.
Fine? Cool. So I hope everybody is clear. I assumed I have defined X as a dash O cap BC, and I just have to I have to show that BP SX is cyclic. The other would follow due to symmetry.
How did you show x uh, in lies on perpendicular bisector of PQ?
Because of the okay, so is it clear why a dash x over xo? Okay, so is it clear why xm is parallel a dash?
Yes.
What was M again? Can you?
M is the midpoint of PQ.
XM is parallel to A. Yes, that's clear.
So this is the ratio I did. Is a m over m. Yes. So this is what I proved. So because of this, xm should be parallel to a dash. But observe a dash is perpendicular to BC
AM
and to
over
PQ.
A,
Yeah.
AM over what?
AM over MO.
Oh, can you go up a bit? Can you please go up a bit, sir? Up, like to your that's yes.
Good. So I have shown xm is parallel a dash, but a dash is perpendicular BC and hence perpendicular to PQ. So I have shown xm is perpendicular to PQ. Fine. But M is the midpoint, so it lies on the perpendicular bisector. So xm must be the perpendicular bisector of PQ. M is the midpoint of PQ. And I'm drawing the line through the midpoint, which is perpendicular to the segment. So it's a perpendicular bisector. Fine. Oh, I have not shown that BPS and CQS meet on A dash show. I have not shown that. I am assuming X is this, and now I have to show the cyclicity. So we are kind of, we wanted to do this, but okay, I thought defining X as the other thing is better. So should I go over any part once more?
Sorry, I forgot. How did you prove that A dash is perpendicular to XM? Parallel to XM?
This ratio. You just drop perpendiculars onto PQ and BC, and that's all just the ratio chasing. So this proves XM is parallel to PQ. XM is parallel to, what am I saying, A dash.
Could you show the diagram?
Yeah. Okay, so in order to show BPSX cyclic, what do I need to show?
Angle BPC is equal to MM dash C.
Angle BP.
MXC, sorry. No, wait, actually I have some difficulty like deciphering the diagram.
Yeah, sorry, that is why I told you please make your own diagram. I'm really bad at making diagrams, and I work with bad diagrams.
So,
Okay, so I'll draw one more here.
We need angle BSP is equal to BXP.
BSC is no BS.
We need BPSX cyclic, right?
Yes.
Then could we show BSP is BXP?
Yeah. Okay. Okay, so we know angle. Great. And that's the final idea as pointed out in chat. So we know angle PBX. This angle is known to us, it's angle B. Great. So we want to show angle PSX is 180 minus B. Right? This is what we want to show. When I write an exclamation, it means I want to show. So I want to show this angle PSX is 180 minus B. So what do? I extend this line to intersect this circle again. And this is again where we see the idea of introducing second intersection. We have one intersection with this line marked. We have this line and one intersection is marked. Just mark the second intersection. Firstly, it completes the figure. And as I said before, maybe some more information is hidden with the second intersection. So let's call this Y. And what do I want to show? I want to show that angle PSY is B. Is this clear to everyone?
Yeah, it's clear.
Yes. So angle PSY is B is same as showing this angle is B.
So then we want AYQP isosceles trapezium.
Yes. So PSY is same as PQY, but I know that this angle is B because this angle is B. So I just want to show that AY PQ is isosceles trapezoid. So they have to share the same perpendicular bisectors. AY and PQ share the same perpendicular bisectors. That's what I need to show. So we already had something about the perpendicular bisector of PQ, right? We know that the perpendicular bisector of PQ is XM. So I want to show that XM is the perpendicular bisector of AY.
So XA is equal
So
to
we want XA prime to like equal X whatever that intersection was.
Yes. So we want XA equals XY. And well, okay, I'll give you some time to think about it.
XA equal to XA dash.
Yes, that's good. XA equals XA dash.
So we want to show A dash Y has the midpoint X.
Yes, okay. So now it just details like well the way I finished it is so where is this? So observe XA is all XA is anyways equal XA is XA dash, and I want to show this is also equal to XY. This is what I want to show. So redefine Y as reflection of X over reflection of A dash over X. And now you do have this 90-degree triangle You have the midpoint here. And the perpendicular, okay, the circle is not there, so maybe forget about it. And the perpendicular bisector of AXY will be the angle bisector of this, right? Perpendicular bisector of AXY will be the angle bisector of AXY because XA equals XY. Per bisector of AY is angle bisector of AXY. And we have shown before that this is same as this angle bisector is XM, which is just XM. Remember, we had all of these equal angles here.
Sir, but you just showed that we have one isosceles trapezium on APQ. How do you show that this y not y, let us call it the one construction of y is y dash, right? This cyclic quadrilateral one, right? So how do you show that? Like I don't get it how we do go from
Okay,
this
so
definition of
I'm
y
just
to that.
defining y as reflection of A dash over X. And I
Right.
just want, so do you see by showing AY PQ isosceles trapezoid is same as saying AY and PQ share a perpendicular bisector?
Yes, but I don't know why showing that AYPQ in this new definition of y is the same as showing that we are done.
Oh, I mean the perpendicular bisector is of
No,
PQ.
I get that. But what I'm saying is, in this new definition of y, we are not done, right? In this new definition of y,
I mean, the y, both y and y dash should be reflections of A over this line.
no, but how do you prove that y dash is the reflection of A over this line?
Because it was literal, I mean, just do this, and then now we have AYPQ is perpendicular. AYPQ in this case is AYPQ, and hence S is also this, you get a circle. AYPQ is cyclic. Do you see why AYPQ is cyclic? And
Yes.
I know that S lies on APQ, and I know that this is, so I can just do the same angle chase again. Just get those angles. This angle is this angle is this angle.
I see. But
Okay, so I think I went over this a bit mess. So this went as a bit mess, but I would encourage you to try to figure out it on your own. But are there any doubts in the proof?
Yeah, here with the new definition of y, how did you get AY QP cyclic? Like what was?
Okay,
With the
so I'm
new-
showing AY and PQ share the same perpendicular bisector. Okay.
Yeah, yeah.
Did you see why do you see why I have shown AY and PQ share the same perpendicular bisector?
Yes, then they are parallel.
Yes, so
Oh no, they share the same perpendicular. Okay, fine.
perpendicular bisector, so it's also
Then they are isosceles.
Yes, that's it. Okay, cool. Any other doubts? Yes, that would be good. I'll share the source of it.
Can you please tell how did we finish using isogonal line lemma? That one.
Oh, okay. I'll just come in a second. Copy link address. I'll put it in chat here. Yes, we did not. We just showed key xp should be equal to xq there. Like, if x is this point, we just showed xp equals xq, because p and q should also be isogonal. Okay, wait. I'll go to it. So here, look at this angle. Look at angle AXO. I know B and C are isogonal. So by the isogonal line lemma, AB cap OC and AC cap OB are also isogonal.
Okay, thank you.
So I get P and Q isogonal.
Yes, I got it.
Yeah. Oh, the solution is so neat. Yes, maybe also I think yeah, it was a bit messy from my side to change the definition so many times. Maybe if you read the solution, it will be a bit easier. But the main point of this was to not understand it was important. It's important to understand the solution, but it's also important to understand the motivation why we added the points, because that is the whole point of the class. So we have seen this problem. Ki adding the second intersection is a very important idea, and if you want some angles, then some angle conditions. Adding the second intersection is like, if you have not thought of this in this way before, then you should think of it and this at some point. Then maybe later you'll internalize the idea of just for example, we had a guess ki the second intersection, does it lie on a dash, and maybe later such guesses become motivated. Okay, so I hope there are no doubts, and I'll go to some. I'll pick a easier problem. So if anybody has seen this, let me know. I'll give a different problem.
Can you go down a bit? First thing is we can ignore C, right?
No,
Oh,
how
no,
can
no.
we see? O is
Oh,
the
C.
circle of CPQ.
Oh,
I feel like because we have this thing where CQ is parallel to BA, we might want to extend like PQ and CB to meet at some point because that gives us similar triangles to start with.
Mm-hmm.
Can you draw the perpendicular from O1 to QC? Can you draw a perpendicular from O1 to QC?
Perpendicular from O1 to
QC.
QC, sure.
So we want to show ADO is equal to D by something. Can you label that point K? Perpendicular from O to QC. Can you label it K or some any random letter?
Sure.
Um,
Just give me a second. Somehow my laptop is hanging again.
CD cap circumcircle of ADB seems quite nice because we get an isosceles trapezium.
I see. I think his Zoom is lagging or hanging or something. Let's just give him a minute to join back.
do you think that ADO is similar to DO that thing? Whatever that perpendicular line onto BC was called. You think those are similar?
I mean, like, what's the motivation behind making that claim?
Because I think that O and is on the perpendicular bisector of CQ. PQC, right? Yeah, O is on the perpendicular bisector of CQ. And CQ is nice because it's on a parallel line, it's a continuation of a parallel line. So like it's nice perpendicular to make. It feels nicey. And when you have nicey stuff and the perpendicular, then it feels like it should be similar. You know what I'm trying to say?
Yeah, kind of. But then P is still a bad point. Like, for our purposes, P is not a very good point.
Okay, he joins back. Maybe we can share screen and try to see solve it ourselves.
Yeah.
Yes, somebody
Okay,
solved it
yeah,
already. Very good.
Imagine if
Let
we solve it like before like he comes.
Energy,
That will be
guys.
funny.
We can do energy.
Yeah, let's do that.
Then we can like annotate and work.
Oh, cool.
Yes. Okay.
No
Write down.
anarchy, guys.
If someone has the original question, if someone's taking a screenshot or something.
Oh god.
We don't need that.
Okay, let's have one person make the diagram for now.
I remember the question.
I self-appoint Om to make the diagram as organizer.
The thing is, I am using mouse right now. So
Oh,
if you
What a
see,
that's
diagram.
good, right?
Okay, wait, I'll draw.
like, that's like, okay, this is B
Okay, this looks much more.
and this is C. Okay,
No,
wait,
this is
wait,
this is D. This is D and that is C.
Okay, yeah.
And that is Q. Yeah,
Yeah,
and
yeah.
this is
Don't,
P.
don't draw 3 times, guys. Don't draw 3 times. Okay.
Okay, now let's have like, okay, Om, do you agree it's a good idea to have like PQ and BC meet at some point T?
Sure, you can do anything. Maybe it's
Uh,
useful, maybe it's not.
P is this line, right? P is this line.
Yeah, yes. One guy drawing, guys. Guys, no.
Okay.
Okay, we
let us
don't
just-
draw that circle. Okay, sure.
Wait, why is PQBC cyclic?
Wait.
What? PQBC? Who drew a PQBC?
Who's drawing circle PQBC?
That's what I'm circle BCQ.
Yes, forward about it.
Yes. And this has center O.
Oh, I'm unmuted. Oh, this is
Okay. So perpendicular bisector, perpendicular bisector,
here.
perpendicular bisector,
My nice diagram.
right?
Oh yeah. Now wait. Now just think. Malaysia
Yes.
and that one.
Right.
Okay, yeah.
So do you think DOI is similar to ADO?
Was this like? Okay, anyway, let me.
Wait, someone has solved the problem?
Yeah, someone solved it.
Okay, what?
Wow. What? Oh, wow.
That is insane. The guy who did that like admits hours and stuff.
Can we please have O inside ADB?
Why do we? How do we know
immense
O is inside ADB?
discomfort watching that. No, just like for the diagram.
Oh, okay, sure. But why do you think that O is inside ADB anyway?
Okay, if we write stuff in terms of triangle XQC, do we have a nice characterization of say D, for example?
D in terms of what?
In terms of the stuff in triangle XQC.
I think we should have P, A, and B as the basic triangle. If you get what I'm trying to say.
Also, maybe bashing is quite viable over here, I think.
No, bashing
Because
is
we have a lot of parallel lines we want to prove a perpendicular.
bashing is bad.
So bashing looks like it should
Bashing
be
is
a
bad.
decent option.
Bashing
Sure.
is bad.
I mean, there's
Like
only one
the
important
only
circle over here.
the only quote unquote hard
Two
point
important
is the
circles.
circumcenter of CPQ, which is like the main point, but after that it won't be that hard of calculation. And I'm pretty sure there's formulas for circumcenters.
So
Yeah, there
bashing
is,
is
but
bad.
you don't have to do that. You can just set CPQ equal to unit circle and work with that.
Also the dominance.
But bashing. So
Class is not over. Malay will join in a bit. And
Yeah,
so
there
try
some-
to do like
Yeah, I
syntax.
think complex bashing with taking ABD to be the unit circle should work out quite nicely.
no.
Okay, but let's do synthetic.
Yes. Yeah.
I started bashing the second Malay left. Like, what is this?
No, we're not bashing this.
Yes. Very nice.
Even the bashing is like good, but we'll do it after
No.
class.
Don't worry, we will not bash.
Yes.
Yeah. As long as I'm.
Clearly the bash police is here.
No.
Yeah,
Don't
hi.
use police.
Sorry for that. I didn't know there's some issue
Yes.
with Zoom. I just
Thank
can't
you,
do it.
Malay. Thank you so much to save us from bad.
Extremely sorry for that. Okay, so I heard so this problem is solved. Oh, you're using
Someone solved it. This one person.
1%.
okay, so would someone like to explain the solution? Wait, if you have already discussed the solution, is it clear to everyone?
No, it's not discussed yet.
No, it's not
No.
discussed. Someone just solved it.
Okay, sure.
So do you think ADO is similar to ODI?
ADO similar ODI.
Yeah.
What?
Oh,
That's very good. Oh.
this triangle similar to this triangle.
I have no idea.
I mean, both are 90, and this is nice, and this is nice.
Not sure. I mean, at least. Also, wait, the circle should not pass through it, right?
It's not passing through me.
Yeah.
That's just a weird artifact.
But yes, whoever has solved it, yes, that's the intended solution I have.
Also, I think just to complete the diagram, we could do we could add in DC cap ABD. That might be a good point to add just to make the diagram complete.
DC cap ABD. What does that mean?
I'll do it. Okay, so here the point is O is first of all weird. It's a circumcenter of CPQ, and there's not really direct connection. And D and O seem completely disconnected from each other.
Why do we have? Okay, so can you please draw a QPC circle? Because I always get I'm just getting confused between ABC, ABD का circle and
Wait, I'm there. Can you not hear me?
Yeah, we can
We
hear
can
you.
hear you.
Oh,
Okay.
so I'm
Wait, what did you say, Om?
no, nothing. Yeah.
So again, this problem is again about adding the second intersection. So there are mostly two important things of adding second intersection, which I think it's like you have two circles with one intersection marked, mark the second intersection. And second is if you have a circle and a line marked with and a line with one intersection marked, then just mark the second intersection to make the figure more complete.
We can extend DO.
You can you can extend
DO to D.
Okay, yeah, that is a good idea. You'll get the antipode of A.
Yeah.
But we have to use the parallels. That's the whole point. Like we have two parallel things and we haven't used any of the parallels yet.
Okay, so then
Maybe
once again, I'm just saying that CD cap ABD is a good idea because then we have an isosceles trapezoid.
maybe also extend CB to meet the circle.
Okay, good. This is, I'll call it E.
what about circle CPQ? I mean, that's the main circle that is there, and we have not thought about it.
Okay, so you want me to draw circle CPQ?
Yes.
Good, great. So
Wait, is the screen being shared right now? Because I can only see like the Zoom whiteboard.
Yeah.
Yes, I'm doing Zoom whiteboard.
Oh, okay.
But do you want me to screen share?
Screen
Yeah.
share is better, I feel.
Okay, sure, sure.
Okay.
Oh, I
Okay.
cannot. Can you
Okay.
make?
Yeah.
Yes,
Is it
yes,
enough?
1 second. Now you should be able to.
Yes, I can. I hope you can see the screen. So we had this point E.
Yes.
And we had this circle. Oops.
Why do we know that CPQ is going through E?
That's a mistake. So the last one more thing about the adding about this is like, you all might have heard about dreams, which is if you take two circles and you take two chords to their intersections, then this is parallel. And well, you can just do angle chase. You don't need to remember this as a theorem, but at least when I see two parallel lines, I try to see if I have a circle through one point and so that it's collinear, say, then you mark the second intersection and like not the second intersection, but that's also good. And that's exactly the case here.
Yeah.
Could you please restate how did we define E? Like, is it on ABD or CPQ? Thanks.
We're saying P lies on the circumcircle of CEQ.
Yes, the whole point is P also lies on the circumcircle of CPQ, and this is again just streams. So you do have, you have these circles. This point is P, this point is C. With from P you have a line. This is, I think this is Q, and you have other line through C. This is B, and this is, I think, ABC, and we have these are parallel. So this C must lie on the other circle as well. If you want, you can angle chase as well. My bad. E should lie on the other angle as well. So the point is E belongs to CPQ. But this is basically reams. Look at it this way. You have these two circles and you have this one line through P and the other line through E. Their intersections with the circles are AB and QC and they're parallel.
Wait, can you repeat this after the reams thing?
So I mean, we have done nothing after reams. We just have showed key E lies on CPQ.
Oh.
Okay, if you want me to write the angle chase,
I mean, the angle chase is just clean to state for reams in terms of anti-parallels, right?
exactly, sure. So angle PEC,
Anti-parallel.
angle, let me write angle PEC is equal to angle PEB, which is equal to angle 180 minus angle PAB, which is 180 minus angle PAC. So you get these two angles are equal, so E lies on this.
Oh, right, makes sense.
So that's great. Now we knew O is center of CPQ, so we also know that E lies on this circle. So we have more information. And now, so we want to show DO is perpendicular to AD. What does it reduce to?
DE equals DC. Should happen.
Yes, it reduces to DE being
DO
equal to
bisects
DC.
like BE.
Yes, the point is AD is parallel to BC. So we want to show
would drawing the circumcircle of ODA be an idea? Like, so we can try to prove that OA is the diameter or something.
Not a bad idea, but in fact, in this case, we are just done. I'll tell you why. So we have to show DO is perpendicular to CE, but we know that O lies on the perpendicular bisector, so this line must be the perpendicular bisector. So it suffices to show this DC equals DE, and now O is gone out of the picture. We just don't need O, and this is just angle chase. You just show DC is DE.
Oh yeah.
Yeah, go ahead.
Yeah, nothing. Just
So if you're solving this in contest, you'd probably look at this, but also possibly a number of other different points. And you'd see that all of those others possibly don't work and that this one somehow gives you stuff, right? So like you might consider the other intersection of the circle with CD instead of CB.
Yes.
And you might see that that works or that doesn't work, and you might switch to the other intersection and stuff.
Yeah, I mean, like, you don't have to decide if it works or not. The point is just keep everything in the figure and see what works. Like, because D dash does not work or don't delete it, maybe it works. The point is just keep everything and try to see what works.
I see.
Yeah, so would anybody like to give the angle chase by DC is DE?
We want DC equal to D, right? So
Full angle, so angle like
it just
DC.
suffices because
DEC equals DAB equals DCB.
yeah, exactly.
This angle is this angle is this angle. So I hope the solution is clear to everyone, and we are almost out of time. I'll just give the third problem which I gave as a buffer problem.
How does D equal to DC imply that?
Because so D lies on the perpendicular bisector and O also lies on the perpendicular bisector of CE.
Of CE.
Because O is the center of the circle.
Yes.
Yeah.
Yes. Got it.
So these are some problems that you can try later.
wait, what was the part of the last angle chase again?
Yes, so I'll go over it once more. This angle is this. DCB is DAB, but DAB is DEB.
All right. Okay. Thank you.
So yes, these are two problems you can try, and I really like the second one. I like both of them, but second one I specifically like a lot. Okay, I think that's it for the class. Any doubts?
Okay, I think then we can stop recording.
Yeah. And yes, it's fine if you did not fully understood the solutions to probably the first one, even I was messy, but I hope you got the motivation behind adding the new points and so on. That was the more important part. Solution you can figure out with your own ideas, and you can even try to complete the solution with what you remember from the class. Even that would be a good exercise. And there are other solutions on the thread as well. So yeah.
So do you ever need to make completely new points? Like even in these cases, you're just taking points that already were existing as intersections. Are there questions in which you have to just get a completely new point, which is not relevant, not directly related to what is already in there?
As in, I mean, if you like, for example, in the first problem, introducing the second intersection of the two circles, we had the point X, which is intersection of the two circles. That seems a bit random. I mean, it's just not there. Even the circles are not marked in the figure.
I mean, the circles are there. Like whenever you have cyclic quadrilaterals, you consider circles. Whenever you have any angles, the same angles you consider circles. So other than that, like other than circling everything with same angles and just getting those intersections, are there any times when you actually just make completely new points?
I mean, I don't think you can classify what to add, but like sometime, like you introduce the center of a circle that I don't know how to classify something like
Like
you
complete.
realize, okay, you want this angle, so you get some introduce some points so that you get a nice angle. And yes, okay, I should say this problem is hard. The second one is hard as well. Yes, drawing the accurate circles in the second problem is hard, and even I did not, because yeah. Could you share the sources? Sure. So the first one, I'll send the link again.
Also, I noticed one of your homework problems in the FE thing is from like a contest that was like 2 days ago.
Yes. I mean, the day before it, I was just doing all the problems and I found it. Okay, so the first one we did is, I think it's 20. Which year is this? 20. No, the year is not marked. Bro. Oh, I don't remember. Some year it's a 11.4. The link, I put it in chat. Uh, uh, and the second one, I don't know the source on EOPS. That's the sad thing. And it was there on a Inmo mock. That's all I know. I don't know the actual source of the second problem. If you want, I can find the exact year, but I've given the link in chat. Where is this? Yeah, it's there here if someone wants it again. Oh, if you want solutions to any of the problems I gave yesterday, you can DM me. I mean, I don't have the solutions written up somewhere.
Like, do you know the source, like sources for these problems?
Sources for these problems, sure. The first one is USA TST 2022 P7. Yes, it's P7, and this is 2024 RMM shortlist G3. It's 2024, right? Yeah.
2024 RMO shortlist. RMM.
2023, yes. It was proposed last year, so it goes in 2023 shortlist.